Of e to the x. True statement. Quit ruining for me. Destroying my life. Okay. The derivative of e to the x is e to the x. It's a true statement, but why? So this is actually taught in a lesson earlier than chain rule, and it annoys me because then people just memorize e to the x, e to the x, but they actually have no idea why e to the x is e to the x. So I do them together. I do all the derivatives together with these. So, example 1. Didn't look right for a second there. Okay, I want you to determine the derivative of okay. So when we do anything with an e to the x, you take the derivative of it by rewriting it, ln the base, derivative of the exponent. So this works for e to the x, but it also works for any number to the x, because e is just a number, right? It's 2.7181, 45, 90, 45, something like that. So, what is it? 2.71818, 7181. 45. Okay, I didn't do an extra one in there. Thanks, Nathan. This is why he got 100 and I would have. But it's fine. So, it happens when we have a number to an exponent. You three are slowly killing me. Like I'm dying. Like I'm slowly dying. Like, oh, I'm back again. Stop. Cool. It was close. I'm old, so it's fine. My husband was like, yeah, we're in our 40s. I was like, speak for yourself. I am 39 still. Thank you very much. He's like, yeah, we're in our 40s. I was like, 39. September I'll be 40, but you just talk about your own little 40 self. I'm still in my 30s, sir. But anyways, through that. So if we have a number to an exponent, isn't that fun? A number to an exponent, which e is a number of what?
What?
2.7. There you go.
2.7182818284590 something.
4 or 5. It is 45, 90, 45. That's the starting one.
Okay.
Yep. Just helped you out. Now you can go further. All right. So we have d over dx. This means find the derivative of a number to a variable. Okay? Let's say it's a to the x. Our number is a. Number to the power of a to x. What you do is rewrite it. That's the first step. Then you multiply it by ln of the base of the exponent. So it'll be ln of the number. Then what's the derivative of a to the x? If it's the derivative of ax, sorry. Like 4x would be 4, 8x would be 8, ax would be a. Derivative of the exponent. And it's in brackets because those are chains, right? Little chains attached to each other, so that's why it's called chain rule. So why is the derivative of e to the x e to the x? Well, let's see. So f prime of x, we rewrite it. That's our first step. Ln the base. So ln of e. And what's the derivative of the exponent? It's just 1, because it's 1x, right? So it would just be 1. Now, why does ln e go away? Because I just told you the derivative of e to the x is e to the x. Why does it equal 1? Yes, because ln is just log base e. So if I take ln of e, that's the same as log base e, and then I have an e here. And we know when we have that, what does it equal? It equals 1. Why? Because we can rewrite this as log base e, or log e over log e. Remember, it just splits. You can see I use your calculator, so how you type it in anyways. So you get 1. So this actually turns to a 1. So e to the x times 1 is e to the x. Okay, what if it's not just e to the x?
Is that e to the x squared or
Yeah.
e to the x to the 2?
E to the x squared. Yeah. Thanks, board. I appreciate you. Not. So f prime of x. We rewrite it. So it's e to the x squared. Ln the base of the exponent. So ln e, which we know turns to a 1. And what's the derivative of the exponent?
2x.
2x. So they'll often write it as 2x e to the x squared. But if you write these in a different order, e to the x squared times 2x, same thing as the commutative property of mathematics. Just so you know, if there's a 4 in front, it just stays there. So you'll rewrite it and then do the same thing. Try it out. So our first step is to rewrite it. Now some people will try and say it's ln 4e. 4 is not the base of the exponent. E is the base of the exponent. The exponent is on the e, correct? So it's still ln e, which turns to a 1. And then the derivative of the exponent is 2x minus 3. And e is just a number, right? E is just a number. So what if I do this? Try that one out. So for this one, we rewrite it, because pi is just a number. Ln of the base, so we're going to get ln what?
Pi.
Ln pi. Does ln pi cancel?
No.
No. And then what do I get behind it?
8x
8x
minus 6.
minus 6. Sometimes you'll see it too where they'll reduce to 8x minus 6 and take a 4 out, just, or not a 4, a 2 out, just so you know. So sometimes, like if you see an answer key, it might be like this: 2, 4x minus 3, pi, 4x squared minus 6x plus 1. Long pi. Okay, the one that people forget how to do is if I give them this: f of x equals 4 e to the x squared.
Wait, 4 to the e to the x squared.
Yeah.
Oh.
So e to the x squared is its own entity as its exponent.
It's going to end up being really long.
It's chainy. A lot of chain. Like a staircase.
I don't think there's staircases leading to heaven, though. It's just a...
It is.
See myself as at the two walking down towards heaven. That's how I view this.
I see us still recording. This is quite a... So, for this one, we rewrite it. Yeah, it's just the natural log.
It's a natural log. Why not go NL instead of LN?
Log natural. I don't know. And then ln the base.
That's also on podcast.
Could be true. We don't know. Maybe the French came up with it first.
The French come up with lots.
Yeah, that's true.
Just like revolution. Doesn't always go well.
Okay, good talk. So, and then we follow behind with the exponent, the derivative of the exponent. What's the derivative of e to the x squared?
E to the x squared.
E to the x squared.
Just ignore the ln.
Ln e. We're not going to ignore it because it's important, even though it goes away. And then, chain for days.
Okay, so...
We stop the podcast with some fair questions.
So, when we do the derivative of e to the x squared, it's the derivative of an e, right? So you would rewrite it, ln base, derivative of the exponent.
Oh, so you're basically like taking apart the exponent piece by piece.
Yes. You're chaining. So you have to chain. So you do the base with a chain, and then you have to chain the exponent because it's in e as well. Try that one out. F prime of x, rewrite it. Ln the base, derivative of the exponent. Derivative of pi to the 2x plus 1, you have to rewrite it. That's a 3. Check it. 3, sorry. Rewrite the pi, ln of the base, now here's 1 pi, and the derivative of the exponent, which is 2. And you don't have to rearrange anything, you can just leave it, call it a day. Alright? So I'm going to tell you what I would do if I were me and me was you and you were I think you like that. I would, just so you know, on page 154, if you want to practice for not the diploma, that is not true. Page 154, all the way to 159 is limits review. 158, 159 are AP practice problems. If you see something with like a delta in it or something like this, don't do it. Also, on this test will not be limits as x approaches infinity. Remember I told you we're not doing those ones? Those are going to happen when we get to the actual graphing so that it makes more sense as to why we're doing it. So this, if you see those, don't do them. There's no point here. Could you do them though? Could you just put in a table of values and get really, really large x values to see what the y is happening to? Yes, absolutely. Yes.
Part of like the hard check.
No, this is just if you so feel the need.
The terrible version of it, not 20.
Right? When we're trying to find that.